All right, so square root property and completing the square. Square root property will be the quick part. Completing the square is, I was going to say a little more involved. It's not, it's a lot more involved. It's very formulaic, though. It's just going to take practice, a little bit of grit. You can get through it, all right? But it is a process. So most of what we've been dealing with so far are quadratic equations in standard form, using that to factor and then solve. Okay. Now what we're going to do is dealing with quadratics, not in standard form, called vertex form. We'll delve more into that part of it later. One of the things I want you to note is kind of the key difference between standard form versus vertex form. You'll notice that on standard form, our variable shows up twice in the equation, once squared and once linear. Okay, so we have x squared and we have x, or whatever the variable is. When we're dealing with vertex form, our variable only shows up once. Sometimes it's being squared, sometimes it's not. Maybe it's in parentheses that are being squared, but the big difference is it's there once versus it's there twice. It's the big indication for what form the equation is in. When we have it in this vertex form, we can then use the square root property that says you can square root both sides of your equation, and you'll have the exponent canceled, but just remember that you will have a positive and a negative root, so you'll have two answers to kind of keep track of. So we'll start out really simple, and we look and we see we have a variable squared. We have m squared equals 64. I can square root both sides. And what is the square root of 64? And negative 8. Square root property says we get the positive root and the negative root. So we have 8 and negative 8. If you think about it kind of intuitively backwards, we're trying to figure out what values of m could I square and get 64. Both 8 and negative 8 do that. So I need to make sure that I'm finding all values that work. That's why that square root property gives us the principal and the negative root. Now, in order to do that square root property, what's ever being squared has to be isolated. So right now with x squared, I've got other stuff. I've got coefficients and I've got constants. I need to move those first before I can take the square root. So what do I move first? The 54. So we'll add 54 to both sides. Then what? Divide by 3. What is that going to give me? 18. Now that what's being squared is by itself, I can now square root both sides. So we have x equals plus and minus the root of 18. We have the positive and the negative. And then we want to simplify the square root of 18. What can I split it into?
2 and 9.
2 and 9.
And then you can
And what's the square root of 9?
3.
3.
0, 2.
So we have the positive and the negative root of, or 3 root 2 as our solution. So again, what we're looking for is getting whatever's being squared by itself, and then we can apply the square root property. We have a word problem. Same idea. I want to reiterate with word problems. First, identify what you are solving for. What is it that we need to answer? We have an expert marksman can hold a silver dollar at forehead level, drop it, draw his gun, and shoot the coin as it passes waist level. If the coin falls about 4 feet, use the formula D equals 16t squared to find the time that elapses between the dropping of the coin and the shot. What are we trying to find? Time. What variable represents time? T. So since I'm solving for t, they have to give me information about the other variable. D. What does D represent? Distance. What information did they give me for distance? 4 feet. So we can substitute 4 in for distance. 4 equals 16t squared. Yep. Divide by 16 so we can isolate our squared term. What is 4 divided by 16? 1/4. Now that it's isolated, what's next? Square root. Good. So t equals plus minus what? What is the square root of 1? What's the square root of 4?
2.
So we have two answers. We have half a second and we have negative 1/2 a second. So how long does it take for the coin to get shot? Half a second. Why not the other option? Can't have negative time. So we'll ignore that second answer. A little bit different here. We have a quantity being squared. This whole thing is being squared. So that's still considered isolated. There's no coefficients outside of the squaring. There's no constants outside of the squaring. So we can go ahead and jump straight into our square root property where we will square root both sides. If I square root 3x plus 1 squared, what do I end up with? 3x plus 1 equals what? What am I missing? Plus minus. No. Now we need to finish solving for x. Subtract 1. Now, just for clarity's sake, we want to keep that radical towards the end. So instead of taking plus minus root 2 minus 1, we're just going to put that negative 1 in front. So we'll have 3x equals negative 1 plus and minus the square root of 2. That way there's still plenty of clarity. We want to try and keep the radical at the end of the expression. Subtracting 1, having a negative 1, it's accomplishing the same thing. All right, what about that coefficient? Mm-hmm. And there's our solution. X is isolated. So we have two answers. Okay, you don't have to write them separately, but it's important to note I've got negative 1 plus the square root of 2 over 3. And I have negative 1 minus the square root of 2 over 3.
So on the homework,
Honestly, I haven't... I made this assignment like 3 years ago, and I don't remember exactly what the input looks like. I think there's a plus minus button on there, but I might be mistaken. I'm totally okay with plus minus. We're going to be using plus minus more than anything, especially with quadratic. So as long as your radicals are completely simplified, I'm pretty happy. Okay, so plus minus is fine. All right, that was the easy part. Now we're on completing the square. It's a process. The first two won't be that bad, but once we add in something, it gets significantly longer. It's very formulaic in the process. Step 1, step 2, step 3, step 4. Same thing over and over and over and over. So once you've got that routine down, yes, it's tedious. Yes, it takes a while, but it's not inherently difficult. There's a couple tricks to look for. We're going to go through those. Secondly, use your calculator. It's fine, especially because we're going to be dealing with some fractions. Use your calculator. Keep things as fractions. Third, there's a couple different variations for the process of completing the square. There is a method to my madness, so trust me. If you learned a different way, okay. If you look up a YouTube tutorial later and it shows a different way, okay. But just know there's a reason that I'm doing it this specific way. Trust the process. Okay? So, let's just get into it. The goal with completing the square, the whole point of completing the square, is that we're trying to get a quadratic that's in standard form into vertex form. Okay, so the way that we do that, the big part to take note is we're trying to get this binomial squared. I'm trying to have, instead of 2x's from standard form, I just want 1x. So I need that binomial squared. The only way I can do that is if I have a perfect square trinomial. Because perfect square trinomials always factor to be a binomial squared. So we're trying to get that perfect square trinomial. If I could spell. What's making it so that we don't have a perfect square trinomial is that C value. That C value is stopping us from having a perfect square trinomial. So what we're going to do is we're going to actually change our C value. So the first thing we're doing is we're going to take that C value and we're going to move it to the other side of the equation. So we'll add or subtract in order to undo and move it to the other side. So we have x squared minus 2x equals 10. Leave a space there because we're going to replace it with something else.
Wait, but why?
Because that negative 10 isn't going to help me with creating a perfect square trinomial. So we're basically going to start with a fresh slate, a clean slate, and we're going to decide what the constant's going to be so that we have a perfect square trinomial. Okay, so we want to get that constant out of the way. And then what I like to do is, because we're creating a perfect square trinomial, we're completing the square, I like to draw squares. Just as a reminder of what we're doing. So what we're going to put in that box is the constant needed to make it a perfect square trinomial. And there's a very straightforward formula for that. B divided by 2 squared. We evaluate that, and that tells us what our constant needs to be so that we have a perfect square trinomial. What's the B value of this quadratic?
2.
Close. Negative 2. Doesn't make a huge difference in the end, but I'll show you something in a little bit.
Mm-hmm.
Okay. So I have negative 2 over 2 squared. What's negative 2 over 2?
1.
Negative 1. Okay. That negative 1 is very important. We'll come back to it.
Why don't we put the x?
Because the x isn't part of the... So b is the coefficient of x. It's just the coefficient of x.
So we're never just going to get it.
It's only going to be a number. It's always numerical. Because we're trying to find a constant, right? Constants don't have variables in them. So we just want a constant. We just want the numerical part. And then negative 1 squared is what? 1. So that is what goes in those boxes. This is now a perfect square trinomial. We just made that happen by changing the constant to 1. I add it to both sides, otherwise my equation is not balanced anymore. Whatever I do to one side of the equation, I have to do the other. Perfect square trinomials always factor to be the same way. We're going to get a binomial squared. That's what we want. That's the whole point of doing this whole process. And we look and we say, okay, well, what's the square root of my first term? What's the square root of my last term? And what sign do I have here? Now it's factored. We factored our perfect square trinomial into that binomial squared.
Wait, so we grab x.
We square root A and we square root C. Now notice,
Wait, why is it
say again.
Why is there a plus a?
Remember, that's our formula for perfect square trinomial. The square root, and then we take whatever sign is here, right there. So it's that perfect square trinomial formula. Notice that before we squared negative 1, we had it here. It's the same there. Those are always going to match up. These will always be the same. Okay, so it saves a little bit of time. You don't have to really think about what's the square root. You're just going to have x and then whatever this b over 2 was. And then on the right side, simplify it. What do I get? So x minus 1 squared equals 11. So we've completed the square to write it as a binomial squared. Now we can solve using the square root property.
Bota fé.
Square root both sides. What am I going to get on the left? What am I going to get on the right? What are we missing? Plus and minus root 11. And then get x by itself. Plus 1. And there's our solution. It is not the most efficient way to solve a quadratic. It's not. Okay? No delusions about that. The reason we're doing it is because later in the year, we'll be dealing with some different types of equations. Hyperbolas, ellipses, circles, parabolas. All of those require the process of completing the square. So we're going to practice it on quadratics, which is easier, before we do it with more complicated ones later. All right? So that's the whole point. Also, it's useful for converting equations into vertex form, which we'll cover a little bit later in the unit. All right, so we're going to do it again. What was the first step that we did? Pass it to the other side. So we get x squared plus 3x. We have our square, 1, and then our square. How do I figure out what goes in the square? B over 2 squared. What's the b value for this one? 3. Can we simplify 3 over 2? No. Leave it as a fraction. If you try and write it as a decimal, you're shooting yourself in the foot because you're going to have to undo that anyway in order to simplify your radicals. We don't do fractions, or we don't do decimals. We can deal with the fractions much more easily. So then we're going to go ahead and square it. What's 3 over 2 squared? Yep. Now that we have our perfect square trinomial, believe it or not, we can factor it. So it's going to be x plus or x minus? Plus what? 3 over 2. Same thing that we had there, goes there.
Entendi.
On the right-hand side, use your calculator. I don't care. If you're having trouble with fractions, not a big deal. Use your calculator. If you get a decimal, make sure you convert it back to a fraction. Leave it as a fraction. So math brings up this list. See, the first one says arrow fraction. It's saying, hey, take that number and turn it into a fraction. And then hit enter, and it does the conversion. You could do the same if you ever needed a decimal. You would just go down to decimal. Yeah, so I've got 3.25. If I do math, enter, it says answer, turn it to a fraction, and then hit enter again, and it turns it to a fraction. Okay. All right, so now that we've completed the square, we can solve for x. So what do I do? Good. The left side will be what? And the right side will be? Let's go ahead and write it as 2 separate radicals. Okay, using that quotient rule. Can I simplify square root of 13? Can I simplify square root of 4? What does that give me? 2. And get x by itself. Good. Last thing is we want to combine those two fractions. What do we have to have in order to add or subtract fractions? Good. Do we have same denominators? Yeah, so we'll go ahead and just combine them. -3 plus minus square root of 13 all over 2.
Oh, all over.
Yep. Then you need to get a common denominator. So we'll have one later where we get a common denominator. Most of the ones that you have with completing the square will be about that level. But not all of them. What's the big difference between this and the first two that we did? Yeah, we have a leading coefficient that's not 1. So this is where some of the variations and strategies come from, is how to deal with that 3. There's a couple different ways to do it. And again, trust the process. There's a very specific reason why I do it the way that I do it. Okay, so step 1's still going to be the same. I'm going to move that constant. 3x squared plus 6x plus the square. Good. Now we got to get rid of that, or deal with that leading coefficient.
You divided?
We're not going to divide because I don't want it to go away. All right, so we're going to factor it out. This is where the differences come in. Some people divide it, which is fine for solving, but doesn't help us later on when I still need that 3 to be there. Okay, so we're going to factor out the 3. Okay, so I get x squared, and if I factor 3 out of 6x, we get 2x. Now, you don't see it, but we're actually factoring that 3 out of that square, out of that number that I don't know what it is yet. Okay, I still have this left side is 3 times my x squared times 2x times this number. So in order for my equation to be balanced, whatever I add on the left side here, I have to remember it's being multiplied by 3. So whatever I add on the right side also needs to be multiplied by 3. And that's how we keep it balanced. That's pretty much the only major difference, is that part. Yep. And we're focusing on, I don't know why it's not letting me. We're focusing on this quadratic now. Okay. So what's the b value after I factor out the 3? 2. So b over 2 squared is 2 over 2. Yep. So we put a 1 in both of those. Then to factor it on the left, we still have that 3. Still going to have a binomial squared. X squared plus 2x plus 1 factors to be what? And then the right-hand side simplifies to what? To 5. So we've completed the square. Now we can solve. Is the thing being squared by itself? Not this time. What else is there?
3.
The 3. How do I get rid of the 3? Divide. So now we'll divide. Divide both sides by 3. Now can I square root? Yep. What do I get on the left? What do I get on the right? Now, per our rule for simplifying radicals, we cannot have radicals in denominators. We cannot have fractions in radicals. So now we have to rationalize the denominator. I need to multiply the square root of 3 by something that will let me then take the square root. What can I multiply 3 by so that it becomes a perfect square? 3. The square root of 3 times the square root of 3 gives me the square root of 9. What's the square root of 5 times the square root of 3? So when I multiply those, then I can simplify it and I get plus or minus root 15 over 3. Now I don't have a radical in my denominator, so I'm following those rules for simplifying radicals. And then I need to get x by itself. Yep, negative 1 plus minus the square root of 15 over 3. And then I need to combine those. What do I have to have in order to add fractions? Do I have the same denominator? Yep. Becomes -3 over 3. I'm writing out all of this. I don't expect to see every single one of these steps. You can truncate some of this per your comfort level. No, because the square root of 15 doesn't have a coefficient of 3. All. Then we would just get back to here. I want them to be one expression. So we combine them together to get that. So a little more involved, right?
I didn't get the last step. Y from x equals -1, we went to x minus 3.
I want it as one term.
Oh, okay.
Yeah, one big fraction.
Okay.
Yep. One big fraction when we have that irrational answer. Just so that it models the other ways that we'll end up getting them, because we'll have quadratic formula and other things, and they all end up giving the same thing. All right. Okay, so square root property, but a little bit different. What happens when I solve this? I don't need to make it equal to 0. I've already got something squared. I can do the square root property. But what's going to happen this time that's different from what we've done so far today? So what do we do about that? We write it in terms of I. So we get plus and minus. How do I write the root of 17, negative 17 in terms of I? I root 17. Okay, simple as that. Plus and minus. I root 17. Same idea here. Square root both sides. What do I get on the left? Close. Plus minus. Plus and minus 10i. Then 5. Again, make sure it's in standard form. The real part first, the imaginary part second. All right, we got one more completing the square, but we'll get an imaginary solution this time as well. So what's the step 1? There you go. Second step. Factor out the 5. What do I have to remember about the right side?
You got a time is by 5 as well.
There you go. Okay. What's going to go in the box?
3 over 2 squared.
9
over 4.
Wait, we don't grab the negative.
You can grab the negative.
So it's -3 over 2.
Because that negative will just remind you that when you factor it, it's minus.
Okay.
So 9 over 4. So when we factor it, we have x minus 3 over 2. And then again, just use your calculator. -12 plus 5 times 9/4.
When we factor, we just. Okay. Wait, why is it 3 over 2? We just.
-3/4.
When we factor it, what's the square root of 9 over 4?
So we're just in the square root of.
Yeah. And think about it, right? We squared -3 over 2 to get this, and then we square root it. That's just going back to where we were, right? And on the right, we get -3/4. Again, keep it as a fraction. Now you see why we're going to have an imaginary, because our right-hand side is negative. And then, how do I get rid of that coefficient? Divide by 5. So x minus 3/2 squared equals -3 over 20.
Ah, it's the opposite. Yeah.
Yep.
R1.
Now what? Square root. See, it's just the same thing over and over and over. We have plus and minus root -3 over root of 20.
I'm gonna apply.
So we can do 20, just note there's going to be more simplifying. I recommend simplify the radical first, then rationalize it.
Square,
Okay.
square,
5.
Mm-hmm.
Square root 2.
So the 20 splits into 4 and 5. So we have plus and minus root -3, 2 root 5. Now, what do we multiply the denominator by?
Root 5.
Root 5.
And root 5 over top.
What can I multiply 5 by so it's a perfect square?
5.
When we're dealing with squares, usually we just multiply it by itself. That's going to get it a perfect square.
We always want to have a, like,
Yep, that's what rationalizing is. So our numerator, -15. Our denominator, what's the square root of 5 times the square root of 5? Which is 5,
5.
and then times 2,
10.
10. Okay. Now what? Good. We'll add 3 over 2, plus and minus the root of -15 over 10.
and then
Good, we need that common denominator. 15 over 10 plus and minus root -15 over 10. And how do I simplify that root of -15? I root 15. I root. And there it is. In all of its imaginary glory. You having fun yet? No one ever enjoys completing the square.
I like it.
Thank you. I appreciate that.